Hi, this is Mrs. Kidman, and in this video, we're going to be discussing geometry proofs. So let's take a look at this first one here. Now, the biggest thing between a geometry proof and an algebra proof is the type of information that they give us in our given statements. So with an algebra proof, typically what we're given is something like 6x plus 13 equals 7. Something like that, where it's just a statement, and that's all the information that we're given. In a geometry proof, oftentimes we're given information, such as in this problem, segment AD equals the length of segment AB plus the segment of AC. But in addition to that given statement, we're also given the information based on the picture that's shown to the side of it. And so that picture mixed with our given statement can help us understand the context of the problem and use it to then prove whatever we're trying to prove. So in this case, we're trying to prove that segment CD is the same as segment AB. Well, for this first introduction to a geometry proof, what happens is they actually gave us our statements and we need to back it up with reasons. So with that, all of you should have been given a copy of our definitions, postulates, and theorems. Now, those are not all inclusive, but they do include some of the main ideas. If there's something different, we might add to it later. But if you need to find that, that is on Canvas, and it's a great resource for coming up with these reasons. So let's go through and add these reasons to each statement that's given. So they say segment AD is equal to AB plus AC. Well, how do we know that that's true? Well, that's something that was given to us, right? They told us at the very beginning here that AD is the same as AB plus AC. Now, what they did is they said that AC plus CD equals AD. Now, we need to look at our definitions, postulates, and theorems to decide which of those tells us that this is a true statement. And as you look here, you can see that the segment addition postulate says that we can do this. The segment addition postulate says for any segment, the measure of the whole is equal to the sum of the measure of its non-overlapping parts. So AC and CD are non-overlapping. Therefore, the measurement of the whole thing, or AD, is the same as AC plus CD. So segment addition postulate. Awesome. Okay, then we have that AC plus CD equals AB plus AC. Now what they did here is they took this AD and they substituted in AB plus AC for this AD, right? Because they're equal. So what tells us that we can do that is called the substitution property of equality, which basically says if two things are equal, we can replace them with one another. And then the last thing that they did is it looks like they got rid of these ACs to get CD equals AB. Now, we know that we can subtract something from both sides of an equal sign. And the property that says we can do that is the subtraction property of equality. So that is the way that we would prove that, giving those reasons. So what I want to do is take a look at a couple of other geometry examples. This time, instead of giving us the statements and assigning the reasons, we're going to come up with both the statement and the reason associated with these. So let's take a look at this next one. Given the angle ABD, so that's going to be this angle, is congruent to this angle, CBE. So the blue angle and the green angle are congruent. We want to prove that angle 1 is the measure of angle 1 is the same as the measure of angle 3. Awesome. The first place I want to start is with my two-way table. So I'm going to have a statement, and then I have my reasons. Now, with that being said, what we want to do here is we want to see if there's anything in common here. So as I look just at my picture here, they said the blue one is equal to the green one, right? They're congruent, so they're the same, which means that the measure of those angles are the same. Now look at this. This angle right here, angle 2, it overlaps in both of them. And so angle 2 obviously has to be the same as angle 2 because it's the same angle. We also call that the reflexive property of equality, that like a number is equal to itself. So angle 2 has to be equal to angle 2. And because of that, that means if both of them include angle 2, I could take out the measurement of angle 2 and say that they have to be equal. That's kind of the outline of what I'm going to do here. So let me write it out more formally. So I know that angle ABD is congruent to angle CBE. And the reason why I know that is it is given to us. Great. I also know that angle 1 plus angle 2 is going to be equal to, or the measure of those angles, I guess. So the measure of angle 1 plus the measure of angle 2 is going to be equal to the measure of angle ABD. Why is that true? Well, that is true by the angle addition postulate, which sounds exactly like it's written. The angle addition postulate says that I can add two angles as long as they're non-overlapping to equal the bigger angle, just like the segment addition postulate. Okay, now by the angle addition postulate, that's true. Guess what else is true by the angle addition postulate? That the measure of angle 2 plus the measure of angle 3 equals the measure of angle CBE for the exact same reason, right? And all I'm doing is I'm just rewriting the way that I described that blue angle, that green angle. Instead of calling it angle ABD, I'm going to describe the blue angle as angle 1 plus angle 2. Now, the measure of angle ABD and the measure of angle CBE are equal. And why are they equal? Well, that's the definition of congruence, right? If two things are congruent, that means they're the same size and the same shape. So if two angles are congruent, that means that they have the same measurement. By definition, that's what it is. So then with these two things, I can set them equal to each other because they're both equal to each other, right? So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3 by the substitution property of equality. Okay, and then I want to show that measure of angle 1 is equal to measure of angle 2. Well, if I get rid of this measure of angle 2 on both sides, it's the same measurement, which says I can. That proves that measure of angle 1 equals the measure of angle 3. And what tells me I can subtract the measure of angle 2 from both sides? The subtraction property of equality. Okay, so that's how we would prove that. So you can now see in the previous slide, we were given our statements and we had to assign reasons. Now that's important. Then what really we're doing when we prove something in mathematics, especially in geometry, is we're given this information and we want to use this information, create statements that say, yeah, I can justify why this is true. And then with our justification process, what we then want to do is assign mathematical reasons to why we can do each of those things that we did. So let's look at one more example here. Given B is the midpoint of AC, prove that X equals 7. Okay, midpoint. A midpoint is a point that divides a line segment directly in half. That's the definition of a midpoint. Okay, now that is super important for us to know here when it comes to solving this problem. Okay, so let's use that idea to then describe it. So if B is the midpoint of AC, what that means is these two things have to be equal to each other. And if I set CX equal to 4x plus 14, I can just solve for x using algebra and figure out that x equals 7. So that is kind of the outline that I'm going to do. So my statement and my reason. Okay, so what is given to me? B is the midpoint of AC. If you're ever stuck as to where to start, always copy down our given statements. That's a great thing to have included in our proof. Okay, so B is the midpoint of AC. That means that AB is equal to BC. Why does that mean AB is equal to BC? Well, that is the definition of a midpoint, right? The definition says that it divides it exactly in half. So those two sides have to be equal. And then what we can do is AB equals 6x and BC equals 4x plus 14. Both of these were given information, right? Both of those are given statements based on the information that we have. So that means that 6x equals 4x plus 14 by the substitution property of equality. And then we can keep going here. I'm going to subtract 4x from both sides, and I get 2x equals 14. And by subtracting 2x's from both sides, that is using the subtraction property of equality. And lastly, to get x all by itself, I have to divide both sides by 2, x equals 7, and we can divide both sides by the same number by the division property of equality. Okay, so there is our statement there, and we just went through and we proved that those are true. So again, when we're looking at these geometry proofs, a lot of people get hung up because they're trying to figure out where does it fit? What do I need to say? But before you even come up with your statements and your reasons, rather than doing it statement, reason, statement, reason, statement, reason, the easiest thing to do is come up with your statements. Do I believe this is true? What evidence do I have that shows that? Well, how would I explain to someone that this is true without giving my reasons? Okay, once you have that outline of an explanation, then let's just assign those reasons to it. Just like we did with that first problem when they gave us our statements. They said, well, we know that this equals that. I also know that this equals, like this plus this equals the whole thing. So if this plus this equals the whole thing and this plus this equals the whole thing, then they must be equal. And if they're equal and these two pieces are equal, I can take it out and bam, they're the same. Right? That's the process that we use when we prove these, is we walk through it logically ourselves and then we back it up with reason at the end. And that's how I want you to approach these. So please check out the future videos in which we are going to prove some really interesting theorems, like why vertical angles are congruent, why alternate interior angles are congruent, and why the sum of the interior angles of a triangle equal 180 degrees. So please check out those next 3 videos in which we go through each of those things.